In hypothesis testing, there are two kinds of errors that we can make, type 1 and type 2 errors. Why are they called this? So we can tell them apart. A type 1 error occurs when the null hypothesis is true and we reject it. A type 2 error occurs when the null hypothesis is false and we don't reject it. This is a chart that shows us everything that can happen as an outcome from hypothesis testing. Across the top, we have the true state of nature. This is the truth that God knows. And sometimes he would be the only person that would actually know. So the null hypothesis is true or the null hypothesis is false. On the left-hand side, you see our decision. We either reject the null hypothesis or we fail to reject the null hypothesis. If the null hypothesis is true, but we reject it, this is a type 1 error. If the null hypothesis is false and we reject it, this is the correct decision. If the null hypothesis is true and we fail to reject it, that also is a correct decision. If the null hypothesis is false and we fail to reject it, then that is an error, and that is our type 2 error. I mentioned before that hypothesis testing was like a jury trial. So let's look at these errors in light of a jury trial. In the British and American system, the null hypothesis is that the suspect is innocent. And the opposite of that, in our alternative hypothesis, is that the suspect is guilty. What would the type 1 error be in this context? Remember, the type 1 error happens when the null hypothesis is true and we reject it. So in this case, the type 1 error would be that the person is really innocent and the jury says that they're guilty, and so an innocent person would go to jail. What would be the type 2 error in this context? The type 2 error happens when the null hypothesis is false and we don't reject it. So if the null hypothesis is false, that would mean that the person is guilty. But if we don't reject the null hypothesis, we would say that the person is not guilty and a guilty person would go free. Now again, there are also correct decisions. If the suspect is innocent and they get to go free, that's the right decision. If the suspect is guilty and the jury says they're guilty and they go to prison, that's the correct decision. We might not ever know if the suspect is really innocent or guilty. That's the kind of truth that God knows and the person on trial would know. But we as the jury, we the people making this decision, might not ever know if we made the correct decision or not. Also keep in mind that when we're talking about a jury trial, the jury doesn't come back with a verdict of guilty or innocent. They come back with a verdict of guilty or not guilty. And that is very similar language to how we talk about hypothesis testing. We're going to reject the null hypothesis, or we're going to not reject the null hypothesis. We can never officially conclude that the person is innocent. And in the same way, we can't officially conclude that the null hypothesis is true unless we can take a census and actually find the true population parameter. All we can say is that the null hypothesis is likely to be true, or that we found some evidence against it and we're going to reject it. The significance level we choose, alpha, is the probability of a type 1 error, the probability of rejecting the null hypothesis when it is true. We use the notation beta for the probability of a type 2 error, the probability of accepting the null hypothesis when it is false. Now there's a trade-off. If we make alpha very small, we reduce that probability, then that will increase the probability of a type 2 error and vice versa. But this is why we might want to choose different alphas in different contexts, because that type 1 error could have very serious consequences. For example, if it's a death penalty case, we would want the alpha to be very small. We don't want to convict someone in a death penalty case if they're innocent. And so we get to choose the alpha based on the seriousness of the type 1 error.